Now you see students, I have got a battery of 10 volts. I have got a battery of 10 volts. What does this mean?
So it takes 10 joules of energy to
By heart.
It uses 10 joules of energy to carry 1 coulomb of charge from its negative terminal to positive terminal.
Positive terminal to negative. See, when it comes to battery, what did I tell you? You think that positive charge will move from positive terminal to negative terminal. You assume. See, you have to be attentive in my class. If electron goes like this, then I said, assume that a positive charge has gone like this. Got it now? So electron is traveling, but now you have to think positive charge is traveling. So 1 coulomb of positive charge, okay, 1 coulomb of positive charge, if it leaves this point, goes through the circuit and then returns back, then this has expended 1 joule of energy, 10 joules of energy. It has expended 10 joules of energy. Okay. Now, what are the question asked? Uses of electrical uses of resistance. Okay. Now, I'll come to that. Okay. I'll come to that. Good question. That's a very good question. Okay. Now, instead of taking 10 volts, I will take a battery of V volts. Means V joules per every coulomb. Then I have a resistance here. Let me come to this. So there is a battery that I have connected to a resistor. Okay? Hello? Now what happens? What happens? Come on, tell me what happens. I tell Rajdeep, don't be afraid.
Heat is generated.
So you should, heat is generated when?
When it passes through the resistor.
What process through?
Charges.
Charges pass through. When charges pass through this, you remember long ago, very long ago, when charges are flowing, what do you call that when charges flow? Current. So start using the word current. Better. Correct. Charges flow. Correct. It's charges flow, heat is generated, etc. is correct. But what is the first thing that happens when you connect it like this? Electrical current will start flowing. Correct now? Hello? Agree? So the electrical current will flow. The electric current will flow. I will show the current flowing is I, the voltage is R. Now you see, there are 3 physical quantities here. What are the 3 physical quantities? The potential difference of the battery, the current I, and the resistance R. Understood now? All these 3 are physical quantities. Now, how much will be the current? What is its relation between V and R? If I increase the potential difference, what will happen?
the I will increase.
Why? So that's the thing. Hello, everybody. Right. Now try to understand this. So now here you see, if I have a tank and if I got a pipe here. Okay. So if there is water here. And there is a wall here. The wall here. So what happens now? Tell me what happens. Hello, tell me what happens. Dana? Nothing will happen. Yeah, here really. See, I want you to think. Don't be afraid. But nothing will happen. There will be water in the tank and I have closed the wall. I have closed the wall. Nothing will happen. Now, if I open this wall, then what happens?
Water will go from higher potential.
Thank you so much. Dhanyanad. So, the water will start flowing. Correct? Hello? So, water will start flowing. Right? It will have certain velocity V1. It will have certain speed V1. Correct? Now, suppose at this particular instant of time T1, at the particular time T1, this is the situation. Okay? As time progresses, the height of the water keeps on coming down and the speed of the water will also eventually decrease. Hello? Is it clear?
Yes.
Now, what I will do, I will have one more tap on the top. Okay, one more tap falling down, from which water is falling out. Now, the amount of water that is falling here is same as the amount of water that is leaving. So what happens now?
The amount of water is constant in the tank.
The amount of water is constant in the tank. The height of the water in the tank is constant. Got it? Hello, 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 everybody. So the amount of discharge is constant because the height of the water column is constant. Got it?
Yes,
Are you able to relate all this?
Yes,
Now here, here I am drawing the water here, and I am telling you the velocity of water is v1. Clear? Now, what if I make this outlet bigger? If I make this bigger, what will happen?
More amount of water will go.
More amount of water will go, so I will adjust this such that height is c. So more amount of water will go, height will c. Correct? I will adjust that also like that. But compared to this size of the pipe, if the pipe size is like this, what is the other difference other than the amount of water?
The speed of
Speed of the water. That can also be different, isn't it? Hello?
Yes, sir.
Okay. So the amount of water discharged, the speed at which it is discharged, speed at that it is discharged is controlled by this. Okay, now I keep the pipe like this. So if the height of the water, this is so. If the, so now the pipe size is only so much. Pipe size is only so much. I am not going to alter the pipe. So here the water is getting discharged. So if Q amount of water is entering here, Q amount of water is going out. Now if I increase the height of the water, what happens?
the speed of
The
Water will also increase. The area is same. Speed is increasing. So more amount of water will go out. Correct now? Of course, I have to increase this water because more amount of water is going out. Got it? So now, under the given circumstances, the height of the water will decide how much water is going to go out. Got it?
Yes, sir.
What did I tell you? What is the potential difference of a battery? It is same as the pressure, electrical pressure, electrical tension. I did write that. So battery voltage is also like this. If the battery voltage is more, if the battery voltage is more, then just like this tank height is more. If the tank height is more, the pressure here is more. If the battery voltage is more, okay, same situation. Here, the amount of water discharge is more. There, the amount of current that is flowing out is more. Got it now? So if I increase this potential difference, then the amount of current will also increase for the same resistance. For the same resistance, the amount of current will increase. Got it? Hello?
Yes, sir.
Same like how you have this situation. Is that clear? Now these are fundamental concepts. Hello? So if I increase the height, what happens? For the same resistance,
the amount of current is
amount of current is more. If the height is increased, the amount of water discharges also increases for the, and I am going to maintain the height constant. Same way in a battery, the potential difference is maintained constant because of the chemical reaction. Right? So I told you in one of the slides, if the demand for current is more, then the demand for current is more, then the amount of chemical reaction in the battery will also increase. Right? The same situation. Hello, is it clear to you?
Yes, sir.
Now here, keeping this height C, if I increase the size of this pipe, you said the amount of discharge will also increase. Got it now? Hello?
Yes, sir.
Amount of discharge will also increase. Same way, if I decrease this resistance is decreased. A particular voltage is maintained. Only resistance is decreased. Then what happens? See, now if I increase this potential difference, current will increase. Agree?
Yes, sir.
For a given resistance I will not change. See here in the first experiment, I did not change the diameter of this pipe. The diameter of the pipe was same. I increased the height of the water in the tank. Then what happened? The amount of water discharge increased if the height increased. Got it?
Yes, sir.
Hello?
Yes, sir.
Second experiment. I will keep the height same, but increase the diameter of this pipe. I will increase the diameter of this pipe. Hello?
Yes, sir.
Then what happens? So the diameter of the pipe is equivalent to resistance. If I increase the diameter, the resistance to the water will decrease. Hello? Same way, if I decrease the resistance here, what if I decrease the resistance? Say by increasing the diameter of the pipe, I am decreasing the resistance to the flow. Hello?
Yes, sir.
I am decreasing the resistance to flow. So more water is coming out. Similarly, if I decrease the resistance, more current will flow. Got it?
Yes, sir. Yes, yes.
Are you able to see the relation? So what is the relation? For the same resistance, if you increase the voltage, the current will increase. For the same potential difference, if you decrease the resistance, again current will increase.
Yes, sir. Current will increase or only the speed increase?
Now see, let's not talk about speed. Let's not talk about speed. Okay, let's talk about the amount of water and the current. Amount of water and current equivalent. Now don't get confused. Don't get confused. Amount of water, amount of current. Now don't talk about speed of the water. Don't talk about the speed of the electrons. Got it? So therefore, how will you write this relation? Current is Now I will write like this. Current is proportional to the potential difference. Agree?
Yes, sir.
For a fixed resistance. This symbol indicates current is directly proportional to potential difference provided the resistance is constant. That means if we increase the voltage, the current will increase provided the resistance is constant. Got it?
Yes, sir.
Now, current is inversely proportional to the resistance provided the voltage is constant. Second experiment, the height of the water column is constant. I am increasing the diameter of the pipe. So I am increasing the diameter of the pipe means I am decreasing the resistance. Hello?
Yes, yes, sir.
So did you understand these two relations? Hello?
Yes, sir.
So now I can combine these two and write it as I is proportional to V by R. Current is directly proportional to voltage, current is inversely proportional to the resistance. Hello?
Yes,
Clear? Okay, this by experiment you can find out. You can connect ammeter, voltmeter, you can experiment and you can determine this. Okay, so what this experiment says, that means now these three variables, which is this potential difference, current and resistance, are the three physical variables. What did I say?
They are the three physical variables.
What do you mean by physical variables?
State can
Pardon?
state can
No, that is physical quantity. Physical variable. See, that's what. By heart madbagda. Nodi, na physical variable and physical variable, physical quantity, physical yella same. Hanga. Physical quantity means measurable physical measurable quantities. Okay, are physical quantities. Right. Now, physical variable means, see now, first of all, I, V, R are physical quantities. Now, they can take different values. Variable, they can vary. They can take different values. Got it?
Yes, sir.
So, when you have y is equal to x plus 2, means what? What does it mean? What does the equation y is equal to x plus 2 means? What does it mean? Y is a function of x. Okay. What do you mean y is a function of x?
The x changes, y also will change.
X changes, y changes. Good. That is in 7th standard. Now, so here you say x is a variable. X is an independent variable. Correct? No? See, you have to refine, man. See, your day-to-day activity must be refined. You should be better than what you were yesterday. Not in terms of height and weight. Your intellectual property should increase. That's what you have to keep doing it. See, what is happening is, whatever you learned 3 days ago, you forget today and come. So you are not progressing. You are the same. Because by-hearting will do only this job. But learning will keep on enhancing your intellectual aspect. Your intellectual property keeps on growing. Right. So y is equal to x plus 2. Okay, lower classes, all that you say. Now you say x is a independent variable. Why independent?
It is not dependent on any other variable.
Ha, by English baat chalo ide. No. Why x is a why do you, in this context, why do you call x as the independent variable? Means it can take any value. It has no constraint. I can give x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 10. For example, I can write here y is equal to x square. What are the values of x that you can give here? Any value. What are the values that y will get? What are the values of y?
Square of x.
It depends upon x, no? In this case, y will always be a positive number. X can be positive number or negative number. But y can be always positive. And the value of y will depend upon value of x. So x becomes independent variable, y becomes dependent variable. Got it now? Now, see, listen here. See, in physics, there is something called as qualitative description. Qualitative. So what did I do here now? Okay, I did some empirical observations. What are these empirical observations? V increases for a constant resistance, I will increase. So, from this experiment, my conclusion is current depends upon voltage for a fixed resistance. Next set of experiment, current depends upon resistance for a fixed voltage. For a fixed voltage. Now, all the three are variables. All the three are physical variables. They are physical quantities and they are variables. But they are interrelated. They are interrelated. Okay. So now this interrelation between the resistance, potential difference, and the current was studied by a famous scientist called Ohm. Right? And he gave the famous Ohm's law. Law in physics means relation between physical quantities. He gave the famous thing called as Ohm's law. So his statement was, now the current through a resistor, okay, is directly proportional to the potential difference between its ends. The current through a resistance is directly proportional to the potential difference between the ends of the resistors. So now by connecting a battery, whatever is the potential difference of this, the same potential difference you are applying across the resistor. And then you are seeing the current through it. So this current depends upon the potential difference across the ends. And it is directly proportional. Current is directly proportional to voltage.
So again, the potential difference will be same there, I mean, in the battery as well as in.
Good question. Good. ನೋಡಿ ಈ ತರ ಡೌಟ್ಸ್ ಬರೋದು ಸಹಜ and ಈ ತರ ಡೌಟ್ಸ್ ಬಂದಾಗ ನೀವು ಕೇಳಿ ಗುಡ್. Now you see if you connect a voltmeter here, you know voltmeter? Meter that will measure the, if you connect the terminal, see this will have plus and minus. If you connect the plus terminal here and minus terminal of the voltmeter device, an instrument device, it will show some reading. So if this is 10 volts, this will also show 10 volts. This is 11 volts, this will also show 11 volts. Correct? If it is 0 volts, it will also show 0. So it will show this. Correct now? What is it? It's a voltmeter. What is this called? Voltmeter. I showed you one slide in which I had slightly told you what is a voltmeter. ಒಂದು ತೋರಿಸಿ ಎಲ್ಲ ಮಾಡಿದ್ದೀನಿ, ಎಲ್ಲ prerequisite ಮರೆತೋಗಿದೆ ಹಾಕಿ ವಯಸ್ಸು. So it is a voltmeter. Voltmeter will show you, if I connect a voltmeter here, it will show the, what will this voltmeter show you here? It is now reading 10 volts, and what is this 10 volts for a battery means? It is the EMF. The potential difference here should be interpreted as EMF, electromotive force. The unit of electromotive force is also volts. Got it? Hello?
Yes, sir.
So this reading of the voltmeter across a battery, this reading of the voltmeter across a battery indicates the EMF of the battery. That means this reading will tell you that this battery will expend 10 joules of energy for every coulomb of charge that it is sending it through the circuit. Got it?
Yes, sir.
Now, I will connect this battery to a resistor. I'll connect this battery to a resistor. Okay. Now I will connect this same voltmeter here. This same voltmeter I will connect here. So the voltmeter will also give you some reading. So it will give you X volts reading. Assume it will give you some reading. Now, how do you interpret this reading? So this reading you interpret it as the EMF. Hello?
Yes, sir.
Energy produced for every joule of charge that it sets. 10 volts in this voltmeter reading. See, ಈಗ reading ಕೊಡ್ತದೋ ಆ reading ದ ಮತ್ಲಬ್ ಏನು? ಈಗ ರೀಡಿಂಗ್ ದ ಮತ್ಲಬ್ ಈಗ ಯಾರು ನಿಂಗೆ ರೊಕ್ಕ ಕೊಡ್ತಾರೆ, ಹಿಂಗೆ ಯಾರ ಸ್ಕೂಲ್ಗೆ ಹೋಗಿ ಯಾರೋ ರೊಕ್ಕ ತಂದು ಕೊಟ್ಬಿಡ್ತಾರೆ, 10,000 ರೂಪಾಯಿ ಕೊಟ್ಬಿಡ್ತಾರೆ, ಏನ್ ಮಾಡ್ತೀವಿ? ಅದ್ರ ಮತ್ಲಬ್ ಇರ್ತದೆ, ಹೌದಿಲ್ಲ? Somebody shows you some undue favors, will you take? You will be careful, no?
Yes, sir.
You will think twice, and you best thing for all of you is I will ask my parents. Easily you can escape. But for me, if some very good gentleman from great person comes and gives me money, then what never should I give? ನೀವೇನೋ ನಿಮ್ಮ ಅಪ್ಪ ಅವ ನೆವ ಹೇಳಿ ತಪ್ಪಿಸ್ಕೋತೀರಿ, ನಾ ಏನು ನೆವ ಕೊಡ್ಬೇಕು? Because I don't want to take money, I have to think why that person is giving. Maybe there are some very good people. They will come and say, sir, you are doing a good job, I want to donate some money to your institution. So it will be a noble cause. Somebody appreciates, he wants to give. So should I take or not take? See, with a good will. See, tomorrow when I am also going to leave this world, all this money and all I want to donate it. And so I will also definitely donate it to some good cause. And so I am also going to go and give somebody. So same thing can happen to me. So what should I do? I need time to think. So what should I do? For you, if they give, you will tell I have to ask my parents. You will escape. For me, I will also have. I will ask my wife. Simple. And somebody gives to my wife, she will say I will have to ask my husband. Simple. That is how the things work, no? But problem is both of them are together. If they give, then we'll say we'll discuss it. But then that means you don't want money if he goes. So you supposing he wants to come and give 1 crore rupees. It's a big money. I can't simply say no, etc., etc. Got it now? So these are situations. Anyways, now why did I come into that situation? So interpretation is different. So the voltmeter, same voltmeter reading here and the same voltmeter reading here gives different meaning. Here it means energy given by the battery for every coulomb. And here it means energy consumed for allowing every coulomb to pass through this. Toll naka. Toll, the car goes. So you go from here to here, you pay the toll fees. Hello? So here the voltmeter reading indicates कितना joules मैंने consume किया. इधर ये see देखो अभी there are some toll nakas. So nearby in Hubli some toll naka they will collect 30 rupees when you want to pass. Somewhere they collect 300 rupees. They will suck more energy. 300 rupees means 300 rupees more energy from me. 30 rupees means 30 rupees worth of energy. Got it? So here so here the resistor will consume energy. So this voltmeter will tell you how much energy it is consuming for allowing every coulomb to go.
Yes, sir.
Here it is allowing how much energy it is giving for every coulomb that it sends. Got it?
Yes, sir. Yes, sir.
Here, what does this voltmeter read?
How much
How much energy is given
How much energy is given by the battery for every coulomb that it sends. And here it says how much energy is consumed for every coulomb that it passes through. Got it now?
Yes.
Voltmeter is it. And here also it is, see, the difference of the potential here, potential difference. Here also it is measuring potential difference. Here also it is measuring the potential difference. Got it?
Yes, sir.
Now, quickly. So in the previous circuit that I had drawn here, okay? The previous circuit that I drawn here, I said the potential difference between this point AB is VAB. And the potential, same potential difference comes across this. One way is physically this is connected by this wire. And this wire is a wire which does not have a resistance. That means this wire will not consume any energy for allowing current to pass through it. There no wire, no block. Got it?
Yes, sir.
So whatever is the potential, this if you connect a voltmeter here, this will also give some reading. The same this voltmeter if you connect here, it will also give the same reading. In this case, physically you see this. Now why it does so? Because law of conservation of energy. For every column that it sends some energy. For the same column of charge will have to pass through this. No. Either se gaya. So this carried energy, this consumed energy.
Yes.
So therefore the voltmeter readings must be same. Got it?
Yes, sir.
Provided there is nothing to consume energy here. If something had consumed energy, then the voltmeter readings will not.
Yes, sir.
Yes, sir.
So the voltmeter readings, what does the voltmeter read? It measures energy for every column that is passing between the two terminals. So it is same. Got it?
Yes, sir.
Any other question? If you have a question, you write it. It is 7:45. I'll leave you. Write and come to the class.
Yes.
ನೋಡ್ರಿ ನೀವು ಲರ್ನ್ ಮಾಡಿದ್ರೆ ನಾಲೆಜ್ ಬರ್ತದೆ. ಆ ನಾಲೆಜಿಂದ ಮತ್ತೊಂದಿಷ್ಟು ನಾಲೆಜ್ ಕಲಿಯಕ್ಕೆ ಬರ್ತದೆ. ನೀವು ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ ನಾಲೆಜ್ ಬರೋದಿಲ್ಲ. ಒಂದಿಷ್ಟು ಇನ್ಫಾರ್ಮೇಷನ್ ತಲೆಗೆ ಇರ್ತೈತೆ. ನೋಡು